In today's notes, we are going to be talking about parallel lines cut by a transversal. We have learned about parallel lines. You'll see over on the right-hand side, each of these diagrams has parallel lines that can be notated when you see the arrows. That means that the lines are parallel. And the transversal is the line that intersects these parallel lines. Therefore, this line would be the transversal. And these are the parallel lines. So there's 4 types of angles in parallel lines cut by a transversal, and we're going to talk about those 4 right now. The first kind is corresponding angles, and they are equal or congruent, meaning they have this. The definition is 2 angles that lie on the same side of the transversal and in the same relative position to the parallel lines. So I'm going to demonstrate what that looks like using my transparency. So I'm going to first focus on angle 1. I'm only going to draw my transversal or trace over it, and I'm going to put an arc around angle 1. The angle that would be on the same side of the transversal in the same relative position would be angle 5. And you can see that by sliding your transparency down and seeing that these 2 angles have the same arc length, meaning they have the same degree. So I'm going to label angle 1 and angle 5 as congruent. By putting the same arc around both of them, I'm saying that they're both congruent. Now I'm going to take a look at angle 3 and 7. I know that angle 3 and 7 are actually also the same degree as angle 1 and 5. So angle 7, you'll see, also fits within the transparency, and angle 3 does as well. So I'm going to put one single arc around those as well, which means angle 1, 5, 7, and 3 are all congruent. Now I'm going to take a look at the other 4 angles that are left. I'll start with angle 2. Again, I'm only going to trace over my transversal, and I'm going to draw an arc around angle 2. Angle 2 is corresponding with angle 6. They're on the same side of the transversal, which is the right-hand side, and they're in the same relative position, meaning angle 2 is on the top of these 4 angles, and so is angle 6. You can also refer to angle 2 as being in the top right-hand corner, and angle 6 being in the top right-hand corner of the 4 angles. I'm now going to put 2 arcs around angle 2 and angle 6. That means that they're not congruent to 1, 3, 5, or 7 because those have a single arc, but they are congruent to each other because they have a double arc. I'm now going to twist my transparency around to find out that angle 8 also has the same angle measure as 2 and 6. Likewise, if I slide it down to angle 4, you'll see that that also has the same angle measure. So I'm going to put 2 arcs around angle 4 and 2 around angle 6. This means that angle 2 is congruent to angle 6 and is congruent to angle 4 and is congruent to angle 8. Likewise, is congruent to angle 5, which is congruent to angle 7, which is congruent to angle 3. And again, these are all corresponding angles. The next type of angles we're going to talk about are alternate exterior angles. Alternate meaning opposite side, which you'll see over here in the definition, and the word for outside. So that's an easy way of remembering alternate exterior, and again, they are equal or congruent, meaning they have the same angle measure. So I'm going to start with angle 1 again. I'm going to trace my transversal and put an arc around angle 1. Now, angle 1 is on the outside of the two parallel lines. So think of angle 1 and 2 and 8 and 7 as being on the outside, and then these angles being on the inside because they're between. So if I'm going to find the alternate exterior angle, that means I'm going to have to go to the other side of the transversal, also on the outside, which means I would end up at 7. So let's see if they're congruent by just twisting our transparency around. Yep, they are definitely congruent. So I'm therefore going to put one arc around 1 and one arc around 7. Angle 1 is congruent to angle 7. The other exterior angles are 2 and 8. So let's see if those are also congruent. So I draw my transversal, I put my arc around 2, and then I twist my transparency around until it lands on angle 8. And yep, they have the same angle measure. So I'm going to put 2 arcs around 2 and 2 around 8, which means angle 2 is congruent to angle 8 because they are alternate exterior angles. The third type of of angles is alternate interior. The only word that is changed is interior. So again, alternate means opposite. Interior is another word for inside. And again, they are congruent or equal. So instead of looking on the outside of the parallel lines with angle 1, 2, 8, and 7, we're going to look on the inside. 4, 5, 6, and 3 are on the inside of our parallel lines. So again, this is the inside of our parallel lines, whatever is between them. So with my transparency, I'm going to outline my transversal and put an arc around angle 4. So if we look at the word alternate interior, alternate means opposite side. So the opposite side for 4, which is on the left side, is going to be on the right side. And if it's also going to be interior, then it has to be angle 6. So I'm going to twist my transparency around until it lands on angle 6. And yes, we can see that they have the same angle measure. So I put a single arc around them. Angle 4 is congruent to angle 6. The other 2 interior angles are 3 and 5. Let's see if they're congruent. Angle 3, twisted around to angle 5, and yes, they are congruent, so I'm going to put a double arc around those. And we can say that angle 3 is congruent to angle 5. The last type of angle that we're going to talk about are different from the previous 3, and they're same side interior angles. Same side is pretty understandable, meaning they're on the same side of the transversal. Interior meaning inside. So same side interior, same side inside. So that means that we would be talking about angles 5, 4, 3, and 6 again because they are on the inside. And same side would mean we're talking about angle 5 and 4, or 6 and 3. And we just learned up above that angle 4 and angle 5 are not congruent, nor are angles 6 and 3. Instead, they're going to be supplementary. And supplementary means that they are going to add up to 180 degrees. So if I added angles 4 and 5, they should add up to 180 degrees. So I know already that angle 4 is congruent to angle 6 because we knew that from up here. And angle 5 is congruent to angle 3. So we're going to say that angle 4 added to angle 5 would equal 180 degrees. Likewise, if we added angle 3 and angle 6, they're also going to add to 180 degrees. So let's see if this is true. We know that this is a straight line. A straight line has 180 degrees on it. We also know that the transversal is a straight line, which means it also has 180 degrees. So let's say we made angle 4 50 degrees. That means angle 6 would also be 50 degrees. If angle 4 is 50 degrees and angle 3 lies on the same line, then angle 3 has to be 180 minus 50, or the difference of 180 degrees, take away 50, which leaves us with 130 degrees. 50 plus 130 equals 180. If angle 3 is 130, that also means angle 5 has to be 130 because of alternate interior angles. So if we substitute 50 degrees for angle 4 plus 130 degrees for angle 5, we will see that indeed they do add up to 180 degrees, which means they are supplementary angles.